Hello viewers, in the previous program we learnt about some basic services provided by layer 3, that is network layer of OSI reference model. We have already discussed about two packet switching mechanisms provided by network layer. One is connectionless service, which is similar to our postal system, and other is connection oriented service, which is similar to basic telephone service. We also learnt about IP addressing, classes of IP addresses, which are class A, class B, class C, class D and E. The last topic we learned about was subnetting, which is used to partition a network into subnetworks, also called segments. In this session, let us have a look on another important service provided by network layer. It is known as routing. The main function of network layer is to route packets from one network to another network. Routing is done by a device called router. It acts on layer 3, that is network layer. Router remembers the route by maintaining special table called routing table. Now what these routing table contains? Routing table contains information about the availability of path or route from source to destination. Now who choose the shortest possible path and how? Answer again is router. Router chooses the shortest available path using some routing protocols. These protocols are based on some data structure algorithm called routing algorithm. Different routing algorithms decide the outgoing route for an incoming packet based on various parameters like geographical distance, number of hops, traffic bandwidth, etc. In previous program, it was mentioned that network layer provides connection oriented and connectionless packet switching mechanism. If connection oriented mechanism is used, the routing decision is taken only once and all the packets belonging to same communication session follow the same path. But if connectionless mechanism is being used, router needs to decide the best path for each and every packet. Routing algorithm can be grouped into two major classes: non-adaptive routing algorithms and adaptive routing algorithms. Now in case of non-adaptive algorithm, the path is decided in advance, that is before actual communication takes place. Path is decided beforehand taking in consideration some static parameters. When the router boots up, it is loaded with the predefined routes. This procedure is sometimes called static routing. Non-adaptive algorithms do not select the best route based on current measurements of traffic and topology. In case of adaptive algorithms, routes are not decided in advance. Adaptive algorithms change their routing decision to reflect changes in the topology and traffic. There are many adaptive algorithms. These algorithms differ in the manner they get their information when they update the routes and what metrics are used in them for optimization. As the adaptive algorithms change their routing decision on the run, they are also called dynamic algorithms. Now we will discuss some static and dynamic routing protocols. Let us first discuss shortest path routing. It is simple and widely used routing algorithm. Idea behind shortest path is to build a graph of the subnet with each node of the graph representing a router and each arc representing a communication link as shown on the screen. In this figure, there are many paths available between node marked sink and node marked source. These are sink, A, B, C, D and source. Another path can be sink, G, H, I, source. Another path can be sink, G, E, H, I, source and so on. But we can see that the shortest path available for a packet to move from sink to sources through node E and F, that is sink, E, F, source. To choose a route between a given pair of routers, the shortest path algorithm just finds the shortest path between them on the graph. The shortest path algorithm includes definition of the way of measuring path length. Different metrics like number of hops, geographical distance, and the mean queuing and transmission delay of router can be used. There are several algorithms available for computing shortest path between two nodes of a graph. Most famous algorithm used for finding shortest path is Dijkstra algorithm. Flooding is another static algorithm. In this algorithm, every incoming packet is sent out on every outgoing line except the one it arrived on. Flooding generates infinite number of duplicate packets unless some measures are taken to damp the process. One such measure is to have a hop counter in the header of each packet. This hop counter is initialized with the maximum possible path length in the network. During communication, hop counter is decremented at each hop, with the packet being discarded when the counter reaches 0. Flooding also wastes a lot of bandwidth because in flooding packets are sent on each and every link. Now suppose a node is connecting 4 networks. In case of flooding, incoming packet will be sent on all the links, which results in extra bandwidth consumption on all 4 networks. This extra consumption of bandwidth make this type of routing algorithm very expensive to implement in terms of bandwidth and resources. A variation of flooding, namely selective flooding, is a slightly more practical approach. In this algorithm, the router does not send every incoming packet out on every line. It sends only on those lines which are going approximately in the right direction. This technique decreases the problem of duplicate packets to some extent. Flooding algorithms are rarely used. These are mostly used with distributed systems or systems with tremendous robustness requirement at any instance. This is because by using flooding, packet reaches destination from all possible routes available. Flow-based routing is another static algorithm which considers topology and load before making any routing decision. Topology and load is analyzed before making any routing decision. Router calculates the traffic on the subnet on the run and then routing decision is made. The idea behind the analysis is that for a given line, if the capacity and average flow are known, it is possible to compute the mean packet delay on that line from queuing theory. From the mean delays on all the lines, it is straightforward to calculate a flow weighted average to get the mean packet delay for the whole subnet. The routing problem then reduces to finding the route that produces the minimum average delay for the subnet. This calculation also allows the router to prioritize the traffic and allows router to implement quality of service, commonly known as QoS. Router evaluates traffic based on an ID, route and time of receipt and rate of flow. Now let us discuss some dynamic or adaptive routing algorithms. Two dynamic algorithms are particularly famous and used. These are distance vector routing and link state routing. Distance vector routing algorithm operate by having each router maintain a table giving his best known distance to each destination and which route to use to get to destination. These tables are updated by periodically exchanging information with the neighbors, and special hello packets are used to track neighbor host and updations. In the figure, node A has a route of 2 hops to node D. Then node A gets an update from node C that it has a shorter route of one hop to node D. So, node A will update its routing table. The distance vector routing algorithm use Bellman-Ford algorithm to find shortest path. It use hop count as matrix. The path that contains minimum number of hops from source to destination is considered as shortest path. Routing Information Protocol or RIP is an example of distance vector routing. In RIP, router is aware of its neighbor only. The router is not aware of entire network. All the routes are transferred from router to router. In this way, routes are propagated to all the routers. Every router receives the routing information from its neighboring router, updates its routing table, and also adds its own information. If it has better known routes than that have been mentioned in the incoming routing information and passes the information to next immediate node. Distance vector routing works in theory but has a serious drawback in practice. Although it converges to the correct answer, it is done very slowly. It also suffers from count to infinity problem. Distance vector routing did not take bandwidth into account when choosing routes. To overcome these limitations, new algorithm was proposed known as link state routing. The idea behind link state routing is simple and can be stated as 5 steps. Number 1 is that each router must discover its neighbors and learn their network addresses. Step 2 is that each router measure the delay or cost to each of its neighbor. In third step, each router constructs a packet telling to all it has just learned. In step 4, each router sends the packet to all other routers, and in last step, each router computes the shortest path to every other router. In the figure shown, there are 4 subnetworks connected through 4 routers, namely A, B, C and D. Using link state routing algorithm, each router exchange information about its immediate neighbors and availability of path with other neighboring routers. Now when there is a link failure in case of subnetwork 3, this information is acquired by link state updates as shown in the figure. The router D sends link state update to its neighbor A and C. A and C in turn sends link state updates to their neighbor, that is to router B, subnetwork 2 and 4. Router B send link update to subnetwork 1. This way all the nodes in the networks get the information that there is a link failure between router D and subnetwork 3. Following the 5 steps already mentioned, all the routers gets information that subnetwork 3 is not reachable. In effect, the complete topology and all delays are experimentally measured and distributed to every router. Then Dijkstra algorithm can be used to find the shortest path to every other router. It uses bandwidth as matrix. The route having maximum bandwidth is considered as best route. Open shortest path first, that is OSPF, is an example of link state routing. Each node in network has the entire information of the network. When any change in the network occurred, means if any node is added or goes down, change is propagated automatically in entire network through update messages. The problem of routing has increased many folds with vast increase in size of computer networks. It is practically not possible for each router to have information about so many other routers. So hierarchical routing is a possible solution. As the network grows larger, the amount of resources necessary to take care of routing table becomes enormous, and makes routing impossible. Here appear the idea of hierarchical routing that suggests that routers should be divided into regions, with each router knowing all the details about how to route packets within its own region, but knowing nothing about the internal structure of other regions. Unfortunately, the gains in routing table size and CPU time are not free. The penalty of increasing path length has to be paid. So, Camon and CleanRock in their paper have discovered that the optimal number of levels for n router subnet is natural log n, requiring a total of e into natural log n entries per router. Viewers, nowadays billions of people have portable computer devices and they want to access their normal file systems wherever in the world they may be. These mobile hosts introduce new complications. To route a packet to a mobile host, the network first has to find it. So generally, that requirement is implemented through creation of two new issues in LAN, foreign agent and home agent. Each time any mobile host connects to the network, it collects a foreign agent packet or generates a request for foreign agent. As a result, they establish connection between them and the mobile host supplies the foreign agent with its home and some security information. After that, the foreign agent contacts the mobile host's home agent and delivers the information about the mobile host. Subsequently, the home agent examines the received information, and if it authorizes the security information of mobile host, it allows the foreign agent to proceed. As the result, the foreign agent enters the mobile host into its routing table. When the packet for the mobile host arrive its home agent, it encapsulates it and redirects to the foreign agent where the mobile host is hosting. Then it returns encapsulation data to the router that sent the packet, so that all next packets would be directly sent to corresponding router, that is foreign agent. Another kind of routing called broadcast routing is used when host needs to send messages to many or all other hosts. For example, a service distributing weather reports, stock market updates, etc. In this routing, packet is forwarded to each and every route in the network. Some different methods were proposed for doing that. The source should send the packet to all the necessary destination. One of the problem of this method is that the source has to have complete list of destinations. Another option is flooding routing. As discussed before, it generates too many packets and consumes too much bandwidth. In another algorithm used for broadcasting known as multi-destination routing, each packet contains either a list of destination or a bitmap indicating the desired destination. When the packet arrives at a router, the router checks all the destination to determine the set of output line to be used and includes in each packet only those destinations that are to use the line. In effect, the destination set is partitioned among the output lines. So, today we have discussed various routing algorithms. Two classes of routing algorithms, namely adaptive and non-adaptive routing algorithms, have been discussed. These algorithms are the backbone of communication over the computer network. A new class of routing algorithms called hybrid routing algorithms is also coming up. This is the combination of adaptive and non-adaptive routing algorithms. The field of routing algorithm is ever expanding and happening. Wish you happy learning. Thank you.